This is part 2 of how to build arguments using rules of inference. And in this lecture, we will consider one more example to help cement the concept of how to build arguments using rules of inference. Let's consider these premises. If it does not rain or if it is not foggy, then the sailing race will be held and the life-saving demonstration will go on. If the sailing race is held, then the trophy will be awarded and the trophy was not awarded. These are the set of premises, and from these premises we need to conclude that it rained. Let's say suppose R is a propositional variable which represents the proposition it rains. F is a propositional variable which represents it is foggy. S represents the sailing race will be held. D represents the life-saving demonstration will go on, and T represents the trophy will be awarded. Now we know what is the first step. We need to convert all these premises in their propositional logic form. So let's convert them one by one. This statement, if it does not rain or if it is not foggy, then the sailing race will be held and the life-saving demonstration will go on, can be converted as not of R or not of F implies S and D, right? If it does not rain or it is not foggy, then the sailing race will be held and the life-saving demonstration will go on. This is what this proposition represents, right? Okay. Now this sentence, if the sailing race is held, then the trophy will be awarded, is represented as S implies T. And this sentence, the trophy was not awarded, is represented as not of T. And the final conclusion is it rained can be represented as R. So this is our argument, and we know we cannot directly conclude R from these set of premises using rules of inference. So what we need to do? We need to take two premises at the time and try to apply the rules of inference to them. Like for example, we can take S implies T and not T. S implies T, not T. We can apply rule of modus tollens here, as S implies T and not T will produce not of S, right? This is according to the rule of modus tollens. Okay, please remember that. Now the premise which is left is not of R or not of F implies S and D, and here it is not of S. We can clearly see that we cannot apply rules of inference directly to these two premises to conclude something. Let's take this premise and apply addition rule. Then what will it produce? It will produce not of S or not of D. I will tell you why I am taking not of D here. I can take not of T also. I can take not of R also. But why I am taking not of D, I will tell you in a moment. Now we can easily apply De Morgan's law here and we can obtain not of S and D, right? Not of S or not of D is equivalent to not of S and D. This is according to the De Morgan's law, right? Now let's take this premise, that is not of R or not of F implies S and D. Now let's say suppose this is P and this is Q. We can say that this premise is of the form P implies Q. As we know, S and D is Q. Therefore, this premise is of the form not Q. P implies Q and not Q. We can apply the rule of modus tollens here and can obtain not P, right? Which is equivalent to not of R or not of F. Now again we can apply De Morgan's law here to obtain R and F. Now if we apply simplification rule here, which is one of the rule of inference, we can easily get R from here. That is what we need to obtain, right? R. So we can say that this argument is a valid argument, as we would be able to construct and build this argument using rules of inference. And finally, we would be able to obtain a conclusion using these set of premises. Let me revise these steps once again. We actually took S implies T and not T in the initial stages. From these set of premises, we concluded not of S. Then we applied addition rule to obtain not of S or not of D. As it is already clear why we chose not of D, because we need to obtain not of S and D, which is equivalent to not of Q if we let S and D as Q. After that, we chose this premise and apply rule of modus tollens here, and finally obtain not of R or not of F, which is equivalent to R and F. By applying simplification rule, we finally obtained the conclusion R, which is our desired conclusion. And hence we can say that this argument is a valid argument.